All right, let's look at chapter review packet 7.1.2, describing functions as even or odd. Let's look at number 1, and let's start with A. If f of x is negative x squared plus 2, and we want to decide if it's even or odd, algebraically, we have to show what is f of negative x. So wherever x is, just like we did on that worksheet, we put in our negative x. And then we're going to simplify. F of negative x equals negative x squared is going to be x squared. So then we have the discussion. Is what we just found exactly what we started with? And in this case, yes. So we have found that f of negative x is equal to f of x, which by definition is an even function. Let's look at B. The absolute value of x to the fifth times x minus 1. When we put in negative x in parentheses, wherever x was, what happens? In here, we're going to get negative x to the fifth, but the absolute value of that is going to stay x to the fifth. But out here, this negative x minus 1, has everything changed, or has everything stayed the same? The first part has stayed the same. This has stayed the same. This has changed. This has stayed the same. So in this case, because not everything has stayed the same or everything has changed, it is neither. Let's check C. 3x cubed plus 1 over x. Put in negative x wherever x is. Negative x cubed will be negative x cubed. So we can bring that negative sign out front. And then this negative sign we can bring out front. So now in this case, we changed from a positive positive to a negative negative. So everything changed. So f of negative x equals the exact opposite of f of x. So this one would be odd. Algebraically shown, put in the negative x, decide if it stays the same, if it becomes exact opposite, or if neither.